Okay, so your domain. If you think about your quadratics, all quadratics have the same domain. All polynomials have the same domain. Does anybody remember what that was that you clicked for your domain of a polynomial? All real numbers. So when I look at your domain, you are talking about your x values. And it will be all real numbers. Okay, so we're going to talk about our range. Our range are no longer our x numbers, they are our y values. Okay, so we're going to put this table, and this would be positive, negative, even, odd. So the table is the same as your end behavior table. We're just not going to put up and down in it. We are going to fill these in based on our graphs. So if we have even and positive, what's your end behavior for even and positive? Up, up. So we would have maybe a graph like this. What does the up arrows mean in relationship? Describe what that means. If something's going up, what happens to the numbers? They're going up, so they are increasing, okay? So if we're going to have numbers that are increasing, what inequality represents something that's increasing? Somebody said it. Greater than, right? Okay. So when I have a graph that's even and positive, your y values will always be y is greater than or equal to some number. Do not put a number symbol there when I ask you to answer the question. The number symbol is represented by you are going to have to find that number to put there. Okay? But if both your arrows are going up, your y values have to always be increasing. Okay? So let's think about that along the idea of an even and negative. So even negative means both your arrows will be going down. So if your numbers are going down, what's happening to your numbers? They're going down. They are negative. They are decreasing. So what inequality represents decreasing?
Less than.
Less than. So your inequality then would be y is less than or equal to some number. Okay, so now we have odd. We're going to look at both of these together. So if they're odd, didn't you talk to me or just turn that in? Okay, so if we have odd positive, our arrows are going down and up. If we have odd negative, our arrows are going up and down. Okay? So if this arrow is going down, this is covering all of our numbers that are decreasing, right? All our negative numbers. If this arrow is going up, it's covering all of our positive numbers or all our increasing numbers. Okay? So how do I represent all my negative numbers and all my positive numbers? Somebody said it. All real numbers. What did I say? All your negatives, all of your positive. What word did I say there? all. So it's all real numbers. Okay? When you can say that you're covering all your numbers, then your answer will be all real numbers. So both of your odd ones will be all real numbers. Okay, so you have a table for your range similar to your end behavior. C will be end behavior, and we have talked at length about end behavior, and most of you are extremely good at it. So if I'm giving you a graph, if you want to describe the end behavior, you're still going to use your up and down, okay? But in order to describe it, you're just going to look at your arrows. So your end behavior, you're just going to look at which way your arrows are pointing. Remember, you always are going to do the left side and then the right side. Okay, the next thing that we look at are zeros. And our zeros are going to be your ordered pair ordered pair where it's just an ordered pair on x-axis. So it's going to be a number, comma, 0. And it's an ordered pair, so it's exactly where the point is on the x-axis. You don't take the opposite of it. You only take the opposite if I start at the equation form. And I'm not going to give you the equation for these. I'm going to give you the graph. So you're kind of working back from a graph. Okay, some of the last 4 things will be new to some of you, and some of you it won't. So the first one is max. We talked about max and mins when we did quadratics. Okay, so it's going to be the same type. Okay, so a max is any high point on the graph, and you are going to write it as an ordered pair. Now, for what we're doing, we're talking about any high point. So you could have multiple maximums. Okay? When we did quadratics, there was only either a max or a min. Okay? With our polynomials, you could have both. Okay, so with E is max, F is min, and this would be any low point on the graph. Again, your answer will need to be an ordered pair. Okay, question G is going to look like this. It's going to say F, and then in parentheses it's going to have a number, and then it's going to say equals, and then it's going to have a line, a blank. So F of, say this number was 3, it's read F of 3 equals, okay. What that means is, if you remember, this number is taking the place of x. So what this means is find the y value given the x value. So you're going to be given the X value of an ordered pair, and you have to find the Y value that would put you on that graph. Okay? It's just a different way to write it. It's called function notation. And then we're going to stop with H today. By the way, I could do every letter of an alphabet with any graph that I give you of a polynomial. I could do a definition for every letter of the alphabet. So you'll get adding to this, but we're going to stop at H. So H is going to be f of blank equals a number. Again, you will be given the number. I will choose the number. That's not something you're going to choose. Okay? And so this is the opposite. This means find the X value given the Y value. And we will look at specific examples when we go through G and H. I'm going to give you a set of graphs to put on your other paper. If you want to divide it, like, you know, you can fold it and rip it, or you can get scissors out of the back if you don't want them connected. Okay? But when you're doing this, what you need to be careful of, and somebody in here will probably do this, is I made sure that the X's are on the right and the Y's are at top. So make sure you orient this piece of paper that you're going to glue in the correct way. The person that hands it to you might not give it to you the correct way, so you need to You have glue. If somebody wants to borrow tape, I don't know if the tape dispenser, there's a tape dispenser up here. There's one in the back. I can get you one in the back. Anybody wants the tape instead. If you are separating them, make sure that the graph that you put up top is the same as the graph I just have there. Obviously, the one at the top. Okay, so for each of our graphs, we are going to do our A through H. Okay. If you want to put A, domain, and then write your answer, you can. I'm just going to put A and know that I'm relating it to the exact same order that we just did in our notes. Okay. All polynomial functions have the same domain. What is it? All real numbers. If you ever have a doubt, always choose all real numbers if you're on a standardized test. Okay? B asks you for your range. So you put that table in your notes. You're looking at your arrows. So your arrows, you got one going down and one going up. So they're going in opposite directions, your arrows are. What is your range going to be? Look at your table. All real numbers also, because your arrows go in opposite direction. Okay, C is your end behavior. All you have to do is tell me which way your arrows are pointing. It has to be one of the 4 choices that we've used for the past couple weeks. Down, up. Always go left and then right. Okay, D are your zeros, and you need to list every zero. Zeros are where it crosses your x-axis. So I'd have 1, 2, 3 times it crosses your x-axis, so I have to have 3 zeros listed. So list your ordered pair. So if I count, so this would be -6, 0, -1, 0, and 3, 0. Okay, E is a max. So when I think of a max, think of driving your car on this graph. Where are you going to be at the top of a hill? That is a maximum. So if I'm driving here, I'm at a top of a hill right here. So I'm going to have to write that ordered pair. What is that ordered pair? -3, 6. Okay, so think about the same thing. A minimum would be a low point in your graph. What's the ordered pair for the low point? What's the ordered pair right there? Come on, they're just ordered pairs. 1, 5, 1, -5. Okay, G. If I have, this is the problem I'm giving you, f of 2 equals blank. Where'd the 2 come from? Miss Harrison just made it up because it's her favorite number. Okay. So I will give you the number there. Okay, what this means is this 2 is an x value. So on your x-axis, go to 2. Here's 2. And then what's the y value that will put me on this graph? Where am I moving on my y-axis? So if I go over 2, then I'm going down 1, 2, 3. So my answer is -3. It's the same thing as writing the ordered pair to -3. You just write it differently. It's called function notation. Let's do another one. Let's do -5. So I'm going to go to -5 on your x-axis. 1, 2, 3, 4, 5, and then what's the y value? 2. Okay, H is the opposite. So I'm giving you a y value. So I'm going to go to 5 on my y-axis. 1, 2, 3, 4, 5. And I'm going to draw a horizontal line. How many times did that horizontal line touch my graph? 3 times, right? You have 1, 2, 3. So how many answers do I have here? 3. And you have to tell me what those are. Now, the hard part of this is they're usually not like pretty numbers. So you're going to get some leeway, but you should be somewhere close. So if I look at this point here is between -3 and -4. So choose a number between -3 and -4. I don't know, -3.5. You could have negative 3.3. That's still acceptable because it's an approximation. If I look at this point right here, somebody approximate what that point would be on my x-axis. -1, -2, so it's between -2 and -3. Give me a number. -2.2. That looks even better. I had two favorite numbers there. Okay, and then the last one, I'm going to count all the way over here. So this is 1, 2, 3, 4. So it's between 4 and 5. Give me a value between 4 and 5. 4.5. Sometimes it will only touch once. Sometimes it will touch multiple times like that. And you have to list every time. Okay? Okay, the second example. Start with your domain. What is your domain? All real numbers. Now, your range. Pay attention to your arrows. Which way are both your arrows going? They're both going up, so that means your y values are increasing. So what is going to be your range? Look at your table. Y is greater than or equal to, and you have to go to your lowest point. So what's the y value right here? -6. So y is greater than or equal to -6. C should be very easy. Tell me which way your arrows go. Up and up. D, how many times do you cross your x-axis or touch your x-axis? 4. What are they? So in other words, all I'm doing is asking you to list an ordered pair. The first one is -3, 0. Next one, 2, 0. 6, 0. And the last one, 8, 0. Okay, max. Where are the top of your polynomials? Where's the top of the hills? How many do you have? So how many, if you're driving your car on this, how many hills would you have? 2. There's one here, and there's one here. Even though it's not marked by a point, there's still 2. So you need to tell me those ordered pairs of your 2 max. So the first ordered pair would be at 1, 3. And the second ordered pair, 7, and it's over 1, so you're going to have to put like 1.2 or 1.3 or somewhere approximate there, but you can't put 1 because it's above 1. Okay? How many low points on your graph do you have? Think about this. Where would you go to be going down and then you turn to go up? There's 3. There's one here, here. So you have 3 minimum points. This is a min, a min. Okay, so list them. Your first minimum would be at what? -3, 0. The next minimum, 4, -6. And the last one, 8, 0. Give me a number between -5 and 5.
3.
Okay, heard that one first. So I want you to find f of 3, which means you're going to go to 3 on your x-axis, and then I'm going to go down how many to touch my graph? So -4. Give me another value. -2, okay, we'll do -2. We need to do a negative. Okay, so if I go to -2 on your x value, how far up are you going to touch your graph? So maybe 0. I don't know, whatever you consider that. How far up did you go? 0.1? Probably more than 0.1, but 2, 3, something like that, 0.25. So it's more than 0, but less than 1. It's actually less than a half even. So, this is paper and pencil. Part of it. Yeah, you're not doing this on Math Excel. We are going to do it on Desmos. We just won't get, well, this class probably get to it today. We can do it on Desmos, or we can do it tomorrow on Desmos. Okay, the last one, f of something equals, we'll do -4. Okay, so you're going to find -4 and you're going to draw your horizontal line. So 1, 2, 3, 4. How many times do I touch? 2 times. And what are the 2 x values that I touch at? To get to this point right here that I just made, what would I go on my x-axis? 3. And to get to this point, I would go 5. So you have 3 and 5.